Okay, now we have stayed on derived units. Now in our previous class we derived some units like volume, area, volume, and density. Now in this class we derive some other units, which is velocity and acceleration. Now these quantities that you see here, they are derived quantities, so we must make use of fundamental quantities in order for us to get their units, the derived units. Now the first one here is acceleration. Acceleration has the first one here is velocity. Velocity has a formula, a very simple formula, which is given to us as distance all over time. And distance over time is the formula. And this distance is measured in the form of length, and the distance has the units of meters. Then time is also a fundamental quantity, which we stated from the beginning, and time has a unit of seconds. So distance has a unit of meters, because distance is measured in meters. Time is measured in seconds. So meters over seconds is given as meters m over s, which is given in turn as meters per second. So the unit of velocity is meters per second, or can also be written as ms minus 1. So the unit of velocity as a derived unit is meters per second, or ms raised to the power of minus 1. We have the second one there, is what we call acceleration. Acceleration is also a derived quantity, and acceleration is gotten by combination of some fundamental quantities. Now we work on acceleration. Acceleration has a formula, and the formula for acceleration is what we know as velocity all over time. Velocity over time, and we know that velocity is a derived quantity. We must know the fundamental quantity to get the answer. Time is a fundamental quantity, this is a derived quantity. And we know that velocity being a derived quantity, we have to break it down because it is a derived quantity. Velocity being a derived quantity is given as distance or displacement, any of them, depends all over time. Now, velocity is displacement over time or distance over time. Acceleration is velocity over time. So in this case, we'll now say in place of velocity, we'll put distance all over time again. Now, distance over time is velocity. Velocity over time, this is velocity, and this is time. So what we're going to do now, this invariably means distance over time divided by time. That's what this means. Distance over time divided by time. So now I'm dividing, I will now say distance over time times 1 over time, because I need to invert what is here. So this can now be distance all over time times time. That's what we have here, distance over time times time. So distance, we know distance having a unit of meters, and we know time having a unit of seconds times seconds. So meters is given as m, seconds is given as s times s, which is m all over s squared, which is written as meters per second squared. Meters per second squared, or can be written as ms raised to the power of minus 2. So the units, the derived units of acceleration is meters per second squared, or ms raised to the power of minus 2, and also the derived unit of velocity is meters per second. So in our next class, we will still be dwelling more on derived units. Thank you.